Hi everyone, in this video I will present to you the tangent and the cotangent functions. Okay, the tangent functions. So consider the function y equals tan x. So to graph this, we need to give values for x. So we have multiples of pi over 4. So if you can still recall, tangent of an angle is y over x of the coordinates here of the terminal point. So y coordinate over the x coordinate. So for example, for x equals 0, tangent of 0 is, so the tangent of 0 is 0 over 1. So 0 over 1 is 0. So we have a point 0, 0, so it's here. And then for pi over 4 is here. So tangent of pi over 4 is y over x. Square root of 2 over 2 over square root of 2 over 2. So that is 1. Okay, so we have pi over 4, 1. So we have here pi over 4 here and then 1. So it's here. And then pi over 2. So when x is pi over 2 here, that means to say in the unit circle, the angle is pi over 2. So we have y over x, 1 over 0. So 1 over 0 is undefined, so we don't have a value for pi over 2. Meaning to say pi over 2 will not give a real value for y. So this pi over 2 must not be in the domain of y equals tangent x because we don't have a y value for this value of x. And then if we have 3 pi over 4, so this over this, that's negative 1. So 3 pi over 4, negative 1 is here. And then if it's pi, 0 over negative 1, that is 0. So pi 0 is here. And then if we have 5 pi over 4, so that's this, negative square root of 2 over 2, over negative square root of 2 over 2, that is positive 1. So positive 1, so 5 pi over 4 is here, positive 1. And then for 3 pi over 2, that's undefined also because that's over 0. So this 3 pi over 2 is not also in the domain of the function y equals tangent x. And then for 7 pi over 4, this over this, that's negative 1. So 7 pi over 4 is here, so negative 1. And then for 2 pi, we will go back to 0. And then if we will give more values, these values will just repeat. And then if we give values in between these values, we can have points somewhere here and then go. It will go as you move your x, as you make your x approach pi over 2, it will just go up there. And then if here, it will just go down here. So the graph is or the graph looks like this. If you will give more points, as what you can see, pi over 2 here, x equals pi over 2 is a vertical asymptote. The graph will approach that but will not meet it. Same here, if we are from the left, it will go just up there. And then if we are from the right, it will just go down here as you approach x equals pi over 2. Same with 3 pi over 2. So what is the domain of this function? So unlike the sine and the cosine function that the domain is the set of all real numbers, this time here for the tangent, we have some restrictions. We are not allowed to have pi over 2 and 3 pi over 2. And if we will explore more on this, the others are 5 pi over 2, 7 pi over 2, and so on. So all the odd multiples of pi over 2 are restricted, are not allowed in the domain of the function. So we can write it this way. So the domain is the set containing x, element of the set of real numbers, such that it is not equal to this value. Okay, this one will give us the odd multiples of pi over 2. So 2k plus 1 will give us an odd number, integer, and times pi over 2. Okay, so all real numbers can be in the domain except the odd multiples of pi over 2. For the range, as what you can see, it can go down here and then it can go up there. So the range is the set of all real numbers. So that is from negative infinity to positive infinity. For the period, okay, we have pi, because that's like this one whole cycle will repeat. Okay, this one. From pi over 2 to 3 pi over 2 cycle. Because actually, if you will join, if you will extend it here, it will create another like that. And then if you have more, it's like this. So one cycle is just this one. So from from pi over 2 to 3 pi over 2, if you just subtract that, you'll have pi. So that is pi units. So every pi units, you will have this kind of graph. So it's one cycle of the graph of the tangent function. So the period is pi. So for this tangent function, the formula for the period is pi over b. B is the number here with x. Okay, here, b. So pi over b. So in this case, it's pi over 1. So pi. Okay, what will we have for, what changes will we have if we multiply tangent x by 2? What if our function is y equals 2 tan x? What will happen? It will just be like this. It will be a bit steeper, steeper here. The red one is y equals tan x, and then the blue one is y equals 2 tan x. So same vertical asymptote, same domain, same range, and the same period. Okay, it's all the same. Okay, except that this y equals 2 tan x is a bit steep. And then if the number there is 1/2, let's say is less than 1, it will be a bit like this, like a flatter here in this part here. Okay, but then we still have the same domain, okay, because we have same vertical asymptotes here, same range, and same period. So the domain is all still a set of all real numbers except the odd multiples of pi over 2. For the range, it's the set of all real numbers, or that is from negative infinity to infinity, and the period is pi. How about number here with x? What will happen to the graph? Okay, as what you can see here, the graph is like twice as many in this frame. So because the period will be affected, so since there's a number here, the period this time will be pi over 2. We have the same, no, the domain now will be there will be more restrictions because the period will be shorter. So actually the period here is going to be pi over 2. Pi over 2 is pi over b. The b here is 2, so pi over 2. So every pi over 2 units, you will have one cycle. So your vertical asymptote here is 3 pi over 4. Here you will have 5 pi over 4, and then 7 pi over 4 here, and then 9 pi over 4. So you will have the odd multiples of pi over 4. Those will be not included anymore in the domain because they will give no value for y. And then if you have like this, number here is less than 1, so y equals tangent x, what will happen to the graph? It will be like this. The period will be longer, and then, of course, the domain will also be different. So the domain this time is what values are restricted for the blue one. You're not allowed to have pi, and then 3 pi. So add multiples of pi. Pi is not allowed. So add multiples of pi can be written this way. Okay, so all real numbers except the odd multiples of pi. And then for the range, the same set of all real numbers, and the period this time is pi over 1/2. So pi over 1/2 is 2 pi. So as what you can see here, if you look at this blue graph, that's from pi up to 3 pi. So that's 2 pi units. Or if you look at this blue graph here, that's from negative pi up to pi. And from negative pi up to pi, that's also 2 pi units. So one cycle every 2 pi units. How about the cotangent function? How does the graph look like? So for the cotangent function, if you can recall, that is x over y of the terminal point. So if x is 0, x over y, 1 over 0, that's undefined. For pi over 4, that's 1. For pi over 2, x over y, 0 over 1 is 0. Okay, so pi over 2, 0 is here. And then for 3 pi over 4, you will have negative 1. So it's here. And then for pi, that is also undefined, no value for that. For 5 pi over 4, that's positive 1. So 5 pi over 1 will be here. And then 3 pi over 2, it's here. X over y, it's 0. So 3 pi over 2, 0 is here. And then 7 pi over 4, that's negative 1. So it's here. And then for 2 pi over 0, it's also undefined. So no value for 2 pi. So if we will connect those, and then if we will add more points, then the graph looks like this. Oh, you should still connect this. So this is still connected here, and then it will just go down there. So that's the graph of cotangent function. Okay, so if you will look at it, it will just go up here. It will not reach x equals 0 and x equals pi and x equals 2 pi. So all the multiples of pi are not in the domain. So the domain can be the set, or is the set of all real numbers except the multiples of pi. So this is how you write it. And then for the range, still the set of all real numbers, so that is from negative infinity to infinity. And for the period, as what you can see, that's also pi. From 0 to pi, that's one cycle. From pi to 2 pi, another cycle. So that's pi. So same with the cotangent. Period is pi over the number here with x, pi over b. Okay, so for if you have same with the tangent function, if you have numbers here, if it's 2 greater than 1, steeper. If it's 1/4, it's a bit flatter. Compare the red one, the y equals cotangent x. So you will have the same domain, range, and period. Okay, so that's it for tangent and cotangent functions. I hope you learned.